Here, we are going to solve for the basis of the range and the rank of this given linear transformation involving matrices. The basis of a range is actually equivalent to the column space of specific matrix here. So in short, this is equivalent to the column space of matrix A. To do this, we are going to show the reduced row echelon form of the two different matrices here, and we're going to pick the columns with the pivot positions, or the pivot columns, and we're going to refer that to the original to come up with our basis of the range, while the rank is the dimension of the basis of the range. So again, we are going to come up with a reduced row echelon form of these two matrices. To start with this, we are going to use this matrix 1, 2, 3, 4. Okay, to make this to come up with this reduced row echelon form, let's make this 0. Since this is already a leading one, we will have here negative 3 of row 1 plus row 2 for a new row 2. So we will have this form here. This is still 1 and 2. So negative 3 times 1 is negative 3 plus 3, 0. Negative 3 times 2 is negative 6 plus 4. We have here negative 2. Next, let's make this a leading one. So we're going to multiply row 2 by negative 1/2. Okay. This would mean we will have here 1, 2, 0, and then 1. To finish our reduced row echelon form, take note that for a row with a leading one, we need to make all other entries be equal to 0. So we're going to move it, use the backward motion. Negative 2 of row 2 plus row 1 for the new row 1. Hence, we'll have here 1. This is 0. This is 1. Then negative 2 times 1 is negative 2 plus 2 is 0. This is now the reduced row echelon form of our first matrix A. Notice that both columns, we have this column 1 and column 2, has a leading 1. This would mean that this two columns now are considered to be pivot columns. Okay? And since row 1 and row 2 are considered to be pivot columns, the row 1 or the row 1 and row 2 of the initial matrix A comprises the column space of matrix A. This would mean that the basis for our range, which is equal to the column space of A, will involve this one here. So we'll have the basis for the range, okay? Range of T, basis for the range of T for this first matrix is a set containing the two columns. We have here 1 and 3, 1 and 3, and we also have the column here 2 and 4. Okay? Or you can rewrite this in form of a vector. So you will have here 1, 3, and then 2, and then 4. This is the basis for the range of T for this specific matrix here. This again, because the two columns has leading 1, hence both columns are part of the column space, which is actually equal to the basis for the range of T. Now, for the rank of T, rank is again simply the dimension of the basis of your range. Since we have two vectors for the basis of the range, the rank for T of T for this matrix A is equal to 2. We have two vectors. This is the rank. These two are the same. They are the basis for the range of T. Let's continue and do the same process for the second matrix A here. Again, let's come up with a reduced row echelon form. So you have 1, 2, negative 2, and negative 4. Let's make this 0. So we'll have to multiply 2 to row 1 plus row 2 for a new row 2. Okay? So we have here 1 and 2 still. 2 times 1 is 2 plus negative 2, 0. 2 times 2 is 4 plus negative 4, 0. Okay? From here, this is actually already in the reduced row echelon form. We don't need to make this 0 since on that specific column, there is no leading 1. So this is now the reduced row echelon form, the second matrix. Now, which of the columns, or are both columns, contain leading 1? The only answer here is this first column, since this second column here do not have or not contain a leading 1. In short, the basis for the range of T for this second matrix is the column, okay, the first column on the initial matrix. So we will have here set containing 1 and negative 2, or you could rewrite this as a form of vector 1 and negative 2. In short, the rank now being the dimension of the range, or the basis of the range, we only have one vector. So you have here the rank of T is equal to 1. So this is the rank of, this is the basis for the range. So this is how we solve the range, or the basis of the range and the rank of linear transformation involving these two matrices here. But of course, before we end this video, take note that the basis for the range here is not unique, as we could also come up with a different form or basis of the range using the row space, because what we use here is the column space. But nevertheless, these are both accepted as forms of the basis for the range of these two matrices. Thank you very much for watching.